Hello, welcome to Level Change channel. My name is Claudio Fonseca. I'm a real world 777 pilot, and this is a very special video. Yesterday I received news from a friend that is going to leave Central America. He's going to leave his 737 to come to the Middle East to fly the 777. He told me that he is using these channel videos to study for the interview and also study for the 777 itself. And as I was also a 737 pilot before the 737, I told him I was going to make this video, and I think this is a very interesting video for many of you, for many virtual pilots that are used to the 737 and now are facing this challenge of flying the 777 in the simulator. So I'm going to try to cover a couple of things that are different from the 737 to the 777. Of course, I cannot cover everything. I'm going to focus especially in the normal procedures, and I prepare a couple of items that I want to talk, but for sure I'm going to remember a couple of things as we do this flight. Okay, the airplane is already ready for departure. Runway 10 left in São Paulo, Guarulhos. We are going to do a departure from Guarulhos, and we are coming back to Guarulhos, so I can show a little bit of the flight as well. But most of this video will be still here on the ground, where I'm going to talk about the main difference between the 737 and the 777, especially the ones related to the normal behavior of the systems in a normal flight. Okay, so first of all, I want to talk about the inertial system, okay, because this is one of the first things that we turn on the 73 and on the 777 as well during the preliminary pre-flight procedure. So the first thing, and here we go inside the airplane, when we go to the overhead panel, you are going to find on the 777 the ADRU switch. Okay, on the 737 you will have it on the aft overhead panel, what we call here on the 777 the maintenance overhead panel. Okay, so for the 737 is going to be here on top, not that high, around this place where we have the CBs. You will find the two inertials for the 737. On the 777 you do not need to go that far. You will find the ADRU system switch here. Basically, on the 737 we have two inertial systems and another inertial system on the electronic standby flight instrument display, on the instant standby flight instrument display. Okay, that's the name for the 73. So here on the 777 is slightly different. You have a couple of inertial systems all integrated in this ADRU, Air Data Inertial Reference Unit system. Okay, which means that the 777 system, even though you have only one system, only one switch, is much more redundant than the 737. Okay, the only thing bad about this system, for example, if you're flying the North Atlantic, you will need to fly between flight level 285 and flight level 410. You are going to need two long-range navigation systems. Okay, and the 777, because the ADRU switch is only one system, the entire ADRU is considered only one system. It doesn't matter how many inertials sensors you have on this system. Okay, so you have on the 777 for long-range navigation systems only one ADRU and two GPSs. Okay, so basically you have three systems for this long-range navigation system. The problem is, on the North Atlantic, to fly between these levels you are going to need two systems operational. So you need the ADRU and one GPS, or both GPSs. Okay, of course, if you have ADRU fault, you are going to have other problems. But the main reason I'm telling you that this can be a problem is because nowadays we are having a lot of GPS jamming, GPS spoofing, and sometimes the GPSs, they do not recover. And then when you are approaching these oceanic points where you need two long-range systems to fly, maybe you are going to be flying only with the ADIRU, and then you cannot occupy basically the RVSM levels. Okay, so this is a problem nowadays. It used not to be a problem when there was no GPS spoofing, when there was no GPS outages around the world due to the war going on, but that's a real problem that we are facing nowadays. Okay, most of the times the GPS, they do recover after you leave these conflict zones, but sometimes it does not recover, and then you have only one long-range navigation system, and maybe you will be limited on these routes. Okay, so this is the first thing. Another thing that the 737 pilots know is that on the inertial switches on the 737, if you want to turn the inertial off, you need to pull the switch and then turn. This is to prevent the inertial system to be inadvertently turned off. Okay, on the 777, to turn it off is much easier. You have a switch. However, in flight, this switch does not work. Okay, so in flight, in the real airplane, if you take the ADIRU switch to off, it stays on. Okay, so it doesn't matter. Of course, I never play with it. I don't want to test itself, but that's what Boeing says. Okay, maybe we can even test here during this flight. Okay, so there is no guard to this switch. It looks very easy to turn it off, but the switch itself is not supposed to work once you are in flight. Okay, then we can talk about the flight control systems. A little bit about the flight control system is that on the 777 you will have fly-by-wire controls. So basically you do not have cables going to all your flight controls, and most important is that the system is designed for the pilot controls and the autopilot controls to go to a computer, and from this computer to the surface itself. Okay, and the 777 has a lot of features that improve handling. Okay, so basically it's much easier to fly the 777 than the 737. Okay, because the flight computers will help a lot. These include configuration changes, algorithms that if you extend flaps, if you extend speed brake, if you extend gear, or if you retract flaps, speed brakes and gears, you will not feel the difference. So the airplane will counteract all these changes on the configuration itself. Also, you have like gust protection. So if you have a gust into a flight, of course you are going to feel a little bit, but it's much better than without this system. And many other improvements on the 777. You are going to see that, for example, if you are maintaining level flight and you want to do up to a 20 degrees bank turn, you do not have to pull or push your yoke. You do not have to pull when you are starting the turn. You don't have to push while you are reverting the turn, because the system commands this automatically. Okay, of course, if you want a high bank turn, more than 25 degrees, and especially the turns that my friend is going to face during the type rating, where he at some point will have to put the 777 to fly with a 45 degrees bank, yeah, then for this turn it's like the standard 737, like the standard conventional airplane, and you are going to need to pull the yoke during the turn, and when you are going to a straight and level flight, you have to push it as well. Okay, so for normal flights this helps a lot. Another thing about the system itself, about the fly-by-wire system, is that the trim during the flight, you are not going to trim for the configuration changes. You are not going to trim for attitude changes as well. So if you are going to only trim for speed. So basically, once you are in flight and you trim the airspeed, let's say for 250 knots, and as long as you maintain 250 knots, you do not have to trim the airplane. Okay, you can put the airplane to climb, you can put the airplane to descend, you can level, you can do turns or whatever, but you do not need to trim the airplane. Okay, then let's say you want to accelerate to 300 knots. You accelerate to 300 knots, you go trimming while you are accelerating. Once you have 300 knots, you trim for 300 knots, and once again you do not change your trim. So basically, as most of our landings, we assume manual control when we are we take over manual control when we are on final with the airplane fully configured and on approach speed. That's usually what happens. So basically that means you do not have to touch the trim. Okay, of course, if you are taking off, usually initially you do not change your trim, but then once we start accelerating the airplane, you have to trim a little bit, and then you trim while you are accelerating until you reach 250 knots, and most probably you're not going to be flying above 10,000 feet. So before accelerating from 250 knots to your final climb speed, most probably the autopilot will be on. So I can tell you that in a normal flight, the 777 pilots, they trim a little bit nose down after takeoff during the acceleration and flap retraction, and that's it. Then you do not fly, and even though when you are coming back to land, when you start flying, usually you are already configured on the speed, so you do not have to touch the trim anyway. Okay, so that's how it goes. That's a couple of things about the fly-by-wire. Okay, about the flaps itself. Okay, let's go down and talk about flaps. Let me try this camera here, because we are going to see here the flap indication and here the flap lever. Okay, basically this flap indication appears when everything is normal. If something goes wrong with the flaps, you have this indication. Then you have basically the indication for the flaps on the left and on the right side. On the 737, as my friend know, you will have the pointers, okay, for the flap moving together. So basically on the flap itself there are two pointers. Usually you only see one because they go together. Okay, so basically it's the same on the 777. If they are working normal, you will have only one indication that reflects the flap on the left and on the right side. If something goes wrong, then you have it splitted, and you are going to see the indications splitted in left and right. Okay, so basically what you are going to have on the upper part are the slats, which right now they are halfway extended, so they are in mid-range, and below you have the flaps that they are now at 5. Okay, so basically what you have is and I'm going to show you this way, which is easier. You have flaps up, so you are going to see the commanded position in magenta. Once it reaches the commanded position, the indication shows green, telling you that you are at that specific position. Okay, it takes a while to retract these flaps, yes. So once it reaches up, it's going to stay green for 10 seconds and then disappears. Okay, so flap up, we can take the chronometer here. We took a while, but you're going to see that in 10 seconds, so basically slightly less than 10 seconds on our chronometer. Yep, you see the indication disappear. Okay, so basically if you do not see flap indication, it means the flaps are up. Okay, and of course if you are going to use the alternate flaps, you will have the indication that flaps are up because nothing is gray here. Okay, so basically there is nothing, so flaps and slats, they are 0. For the flaps 1 that we are going to select right now. Okay, so we just select normal again, flaps 1 magenta. When it reaches flaps 1, it's going to turn green, and once you have flaps, the flaps indication, they stay there, they do not go away after 10 seconds. So basically you have flaps 1. What is flaps 1 on the 777? It's only slats, okay? So only slats, they move to the mid-range. If we go outside, we are going to see that the slats, they moved, but you do not have any trailing edge flaps, okay? So you only have leading edge devices, the leading edge slats and the leading edge flaps, okay? But no trailing edge flaps. Let's continue, and I'm sorry, because of that, because you only have slats, flap 1 is not a takeoff position for the flaps on the 777, okay? On the 73 you can take off with flaps 1, on the 777 no. So 777 basically flaps 1 should be called half of the slats, and that's it. Flaps 5, okay, one more time, flaps 5. You are going to see again that once the magenta indication turns green, you have the flaps 5, and I'm arming the alternate flap arm switch because I want to show the system divided, so I can also show you what are the flap and the slat situation. Right now we still have mid-range slats, but now the flaps, they went from 0 to 5. So if we go outside now, we are going to see that we have flaps, okay, as well. Then the next step is flaps 15, okay? Let's wait the flaps to go to 15. This one is much faster. The problem is from from up to 1 and from 1 to 5, it takes a while. Okay, so now that we have flaps 15, note that slat still stays at mid-range, and now you have flaps at 15. Let's go to the next one, which is flaps 20. One more time, it doesn't take that long to reach 20. Okay, flaps 20, and let me show you that for flaps 20, the slats are still at the same position and the flaps are at 20. Now we are going to see the slats moving again when you go to flaps 25. Okay, as we go to flaps 25, you are going to see that at this time it doesn't show flaps moving because it's moving slats first, and now it's moving the flaps itself. Okay, so basically with flaps 25 you have slats to full extended and flaps to 25, and during this extension what you see first are the slats moving and then the flaps moving to 25. That's why it takes a while for the flap indication starts to move. Okay, and last you have flaps 30. Okay, flaps 30 also moves really fast because these slats, they are already in position, and then you have flaps moving to 30. Of course, if you select from 20 to 30, you are going to see first the slats moving and then the flaps coming down to 30, and what we have now are the flaps and slats fully extended. If we go outside, you're going to see flaps, inboard flaps, outboard flaps, leading edge slats, and leading edge flaps, they are all extended. Okay, what we also have here between these two flaps is the flaperon. So on the 777 you have the ailerons, and between the flaps you have the flaperon. Flaperon basically is a mix of ailerons and flaps. Okay, so the flaperons, they go down as you move the flaps down, otherwise they just work as ailerons. Okay, so if I move my control wheel to the left, you are going to see that the ailerons, they move up, the speed brakes, they move up, and also the flaperon moves up. Okay, if I take it to the other side, you are going to see that the ailerons move down, the speed brakes, they are all retracted, and the flaperon moves slightly down even more. Okay, so this is the normal neutral position. Okay, so this is full right and this is full left. Of course, is the opposite on the other side. Okay, so during normal flight at high altitude, the ailerons, they lock, and all the roll control on the 777 is controlled by the flaperon itself, okay? Of course, when you have no slats, no flaps, the flaperon, the neutral position is streamlined with the wing. Okay, so let's go inside one more time. Oh, by the way, I told you that flaps 1 is not takeoff flaps. So the takeoff flaps, they are 5, 15, and 20, and the landing normal flaps are 25 and 30. For some non-normal situations, flaps 20 is used for landing. Okay, so flaps 20 for landing, yes, but only in non-normal situations. This non-normal situation includes a lot of hydraulic failures, some flight controls failures, and it can also include single engine. Okay, my last live stream was about handling emergencies after takeoff, where we had a single engine, and I showed you that you can land with flaps 20, 25 or 30 if you are single engine, depending on your weight, depending where you are. Okay, so in this case, to define that the single engine flap, you need further knowledge, and you need to understand when you can go beyond flaps 20 for your single engine landing. But yes, it is possible. Okay, I will say that in a standard situation, if you are in doubt, you go flaps 20. If you have performance for flaps 20, if the runway is long enough for you to go flaps 20, you can do flaps 20. It's like the flaps 15 on the 7.3. Okay, so basically you can consider flaps 20 as flaps 15 on the 7.3, especially because when we talk about flap extension and retraction. Okay, so let's come back and let's start from flaps up. Okay, so basically, when you are extending the flaps on the 777, of course, for takeoff, you're going to select the flap that you need. In this case, for example, flaps 5. And what is very easy on the 777 is that your departing flaps, your takeoff flaps, they will always be an indication on your primary flight display. Okay, so basically you are going to see the current flap indication there, and the next flap, the next retraction flap indication will always be there. Okay, so in this case, as we are taking off with flaps 5, you are going to see the flaps 5 bug and also the flaps 1 bug. So when your speed is accelerating above flaps 5 in direction to the flaps 1, you are going to select flaps 1, and then the indications, they change. So you are going to have again flaps 1 and the next flap, which is flap up, and then one more time when the flap when the actual speed is above flaps 1, you select flaps up and you retracted your flaps. Okay, if you are departing with flaps 15, pretty much the same thing happens. You are going to see flaps 15 on your PFD, and then the next indication is flaps 5. So you know that from flaps 15 you go to flaps 5, and then one more time from flaps 5 to 1 and to up. Okay, if you are taking off with flaps 20, you are going to see on your primary flight display the flap 20 indication, and the next one is going to be 5, telling you that from flaps 20 you retract the flaps straight to 5. You do not stop on 15. Okay, so it's much easier on the 777 because you do not have to think about which flap to command. Just look to your PFD. You're going to see that the next flap that is showing on your PFD is the flap that you are going to command. Okay, another thing, usually on the 7.3 we start flap retraction when you are above VREF plus 15. Okay, on the 777 you don't have to think about VREF plus 15 or whatever. You think about your flap position indication. Okay, so what it matters is the flap position indication, and there is no change. Okay, of course you will not be departing with, you will not be taking off with flaps 1. As I told you, flaps 1 is not a takeoff flap, but otherwise you just follow what is on your PFD. Once you are extending your flaps for landing, the standard extension, let me take this out. The standard extension on the 777 is flaps 1, then flaps 5, then gear down, flaps 20. Okay, so you do not select flaps 15 usually. Okay, so on the 7.3 you have flaps 1, flaps 5, and then gear down, flaps 15. On the triple you have flaps 1, flaps 5, gear down, flaps 20. Okay, and then your landing flaps, usually flaps 30, you go straight to flaps 30. Like on the 7.3 you go from 15 to 30 or to 40, but you can also go through flaps 25. You can do the same here. And of course, if flaps 25 is your landing flaps, from gear down flaps 20 you go straight to flaps 25. Okay, anytime you are approaching dual engine and you have your flaps at 30 or 25 and you need to go around, you will go around with flaps 20. If you have flaps 20 or anything less than 20, you maintain that flap for go around. Okay, so if you are starting or go around with flaps 20, flap stays at 20. If you are starting at 15, it stays at 15. If you are starting at 5, it stays at 5. And if you are starting at 1, stays at 1. And if you didn't select any flap, you are going to go around flaps up. Okay, for no normal go around, including single engine, I'm going to leave it for later on. I'm going to help my friend, and I'm going to help also the people that uses the flight simulator at home when we talk about the non-normal situations when we reach that part on our virtual ground course. Okay, so this is something for later on, because basically the checklist will tell you which flap to use during go around. Okay, but have in mind, anytime that the normal procedure or the non-normal procedure tells you to go around with a specific flap, remember that you are going to select that flap if you have a higher flap position. Okay, so you never extend the flaps during go around, please. Okay, so usually people say, okay, go around flaps on the 777 is flaps 20. Yes, if you are with flaps 30, 25 or 20, but if you have less than 20, you keep that flap. Okay, there are no flap extension during go around. Okay, please guys, don't do it. Okay, so I think this covers basically our flaps, and I'm going to set up the flaps for takeoff one more time, which is flaps 5. Okay, so I think this covers flaps for now. For the electrical system is here on the left side on the overhead panel. Important thing is system is completely automatic. Okay, so basically what you have to do, you have to connect the external powers, you have to turn on and turn off the APU, and that's it. Okay, note that the APU generator stays always on, so if the APU is on and the system think the APU is the best for the electrical system, which is basically when you do not have the engine generators running, is going to connect the APU automatically. Okay, so there is no APU start and then APU on bus. Okay, the APU will go on bus automatically by the system. Okay, so after engine start, you do not have to take the generators on the bus. It is also automatically. After landing, you do not have to take the APU on the bus. It's also automatically, okay, done by the airplane. By the way, on the 777 we have two main generators, okay, like the 737. One each engine, and each engine has an extra backup generator. Okay, but have in mind that this backup generator is considered only one. Okay, so as you can see, there is no division here in the backup generator, so basically you cannot connect both backup generators to the system at a single time. Okay, so basically you have one backup generator on the left engine, one backup generator on the right engine, but you can only use one per time. Okay, so in flight, usually when you have a generator failure, you are going to perform on the 777 just like on the 73. You are going to turn on the APU, and then the APU will be your second generator. If then you do not have the APU, or even if you lose the APU, then you are going to have the backup generator taking control of your system, okay? And of course, you need two sources of electrical AC alternate current to continue your flight, just like on the 737, okay? So the only thing is that on the 777 you have this extra backup generator. So on the 737, if you lose one engine generator and also APU, or you lose both engine generators, you have to land. On the 777, if you lose both engine generators and you still have APU and backup generators, you can continue your flight. Or if you lose one engine main generator and the APU is not working, or you lose also your APU generator, you still can continue your flight because you have the other main generator and the backup generator itself, okay? So it's an extra layer of protection on the 777, okay? Next step, we can look at window heat. And window heat on the 777, they always stays on, okay? You do not have indication when they are on. You do not have the green indications when they are on, like on the 737, but basically they are on when the switches are on, and you do not have any fault light like the inop light that is showing here, okay? So basically they stay on. You do not have to turn them on during the pre-flight because usually they are on, and when you are leaving the airplane on your secure procedure, you do not have to take the window heats to off. Usually they stay on, okay? Very, very simple. Another thing, as we are talking about window heat, is the anti-ice system. So the anti-ice system on the 777 basically for flight is automatic, okay? So you have, like on the 73, one control for the wing, for both wings, and one control for the left engine, one control for the right engine. For the wing and for the engine, what is added here on the 777 is the auto position. Usually you're going to keep it in auto position, and in flight, if everything is working, auto position, okay? It's going to turn on and off automatically. You do not have to worry about it, okay? The thing is, the auto function only works in flight. So if you need engine anti-ice on the ground, okay, you need to turn on manually, okay? So remember from the 73, my friend that is flying the 73, he knows about the 73. He knows when he has to put the engine anti-ice on the 73. On the ground is going to be the same thing. You do the same procedure on the 777. Once you are airborne during your after takeoff, you take it back to auto, and the auto handles it until you land. Then upon landing is the same thing. If you need your engine anti-ice, you need to turn on it manually, and then before we shut down the engines, you take it back to auto and you shut down your engines, okay? Another interesting thing is that the wing anti-ice is never used on the ground on the 777, okay? On the 737, there are a few conditions where you need to use your wing anti-ice. On the 777, this is not the case. So the wing anti-ice off and on switch is only used when you have a problem on your wing anti-ice auto system, okay? And then this airplane is amazing. Is also monitoring all the system, including the anti-ice system. So if the wing anti-ice automatic system is not working, it's going to give you a message, and then you just run the checklist, and the checklist basically is going to tell you to run the wing anti-ice or even the engine anti-ice, if that's the case, manually, like you would be doing on the 737, okay? So very, very easy. Next step, something we can talk about is the hydraulic system. Hydraulic system much more complicated than the 737, but much better as well. On the 737, basically you have two main systems, one standby system. On the 777, you have three systems, the left, the right, and the center. The left, you have two pumps, just like the 737. One is the engine-driven generator, generated, and the other one is the electrically generated. So same as the 737. So you have for the left and for the right same thing as the 737, and then on the center system you have 4 pumps. Okay, so 2 of these pumps, they are electric, and 2 of these pumps, they are pneumatic. The important thing, the main system on the 777 is the center, and they all work together. Okay, there is no standby, they are all working together. Why I say the main system is the center one? Because if we go here and we take the hydraulic indications, you are going to see that from the center hydraulic, you have hydraulic for the nose gear and steering, the alternate and reserve brakes, the main gear and steering, the flaps, and the flight controls. Okay, some flight controls. On the left one, you only have the left reverser and some flight controls, and on the right one you have the normal brakes, the right reverser, and the flight controls. Okay, so basically everything major is on the center system, and of course if you lose the center system, you will have to extend the gear manually, you will have to extend your flaps electrically, and so on. Okay, so basically the only thing that you are going to lose with your left and right hydraulic system is the reverser of that specific engine, couple of flight controls, and on the right side basically you also you will have also normal brakes. Okay, right now the demand pump is on the right hydraulic system here, because we are in takeoff configuration. We are about to take off, so the demand pumps, they are here to supplement the primary pumps in case you need more power on the hydraulic system. Okay, a couple of things about this hydraulic system also is that on the 777 the fluid, they can transfer between the systems. Okay, it doesn't happen on the 73, but on the 777 it can happen, especially when you have the right hydraulic system not powered and you are dealing with the parking brake, because remember, the brakes, the normal brakes are on the right side, so the parking brake usually is pressurized by the normal brakes, and then if you do not have that system pressurized and you are working on the brakes or something like this, you are hiding the brakes for some reason, maybe the airplane is under maintenance and you didn't notice this, you may have the fluid that was on the right system going to your brakes, from the brakes going to the center or to the left system, usually to the center. Okay, but of course, as you can move from right to the center, you can also do the opposite. Then you just have to configure the system and do the reverse process. Of course, if this happens, it's not done by the pilot, you call maintenance, and maintenance will sort it out for you. Okay, but have in mind that the fluids can transfer, and because of that there is a very specific sequence for you to turn on your hydraulic, okay, your hydraulic systems. Basically what you want is to pressurize the right hydraulic system first. Okay, so usually, because when you're pressurizing hydraulic system, the right engine is still off, so basically you need the demand pump to auto position, which is going to turn on, and once you have the right system pressurized, you can pressurize the other systems. When you are depressurizing the systems after landing, what you want to do is that you want to turn off the right hydraulic system off as the last one. Okay, so basically you turn off left and center switches to off, and then the last step is to take the right hydraulic system to off. Okay, so basically right one is the first to turn on and the last one to turn off. If you do it like this, you will not have a problem with your hydraulic system in terms of fluid transfer. Okay, so let me see what else I have. Of course, I already told you about the pumps. Basically, you have then 8 pumps instead of 4, so the system is much more redundant, and you have all of them working together. As on the 7.3, well, I don't really remember now about the 7.3, but on the 777, if you have 2 systems working, it's a normal flight. Okay, by a normal flight I mean you can continue your flight. Okay, so you have 3 systems. If you are down in one, you continue your normal flight. Of course, you're going to think about maintenance after the landing and so on, but for your flight you can continue. You have to land when you are left with only one hydraulic. Okay, it doesn't matter which one. And then, of course, if you lose the left and the center, or the right and the center, you are going to have some more problems on this approach, because you have to do a couple of things manually, like the gear, and not manually but electrically, like the flaps. Okay, of course, if you just lose the center one, it's not a big deal, but those things you will still have to do it manually for the gear and electrically for the flaps. Checklist will cover all of this. Good thing about the checklist on the 777, as we are talking about it, is that the checklist is smart enough to give you the, let's say you just lose your left hydraulic system, is going to give the left hydraulic checklist. If you lose the left and the right, is going to give you another checklist, which is the combination of the left and right. Okay, you just have to be a little bit cautious when you already did one checklist and then you lose the other system, and then you are going to the system combines both of them in one checklist. A couple of things that you did before, maybe you do not want to do it again, but you are going to get all these details during your type rating. Is not a big deal. Electronic checklist is amazing. Okay, about the engine start on the 777 is automatic. Basically, you have the auto start button here. You keep the auto start on when you want to start your engines. Let's say it's the right one, you take the button, the start button to start, and you come all the way down here and you take your fuel control switches to run, and that's it. You do not have to worry about it anymore. The only thing that you have to check after the engines are stable at idle, you need to have oil pressure. Okay, that's the only thing that the system does not monitor on the new airplanes. Okay, some old airplanes, they also do not monitor oil temperature, but the new ones, they do monitor oil temperature, including during the engine start. Okay, so once the engine is stable at idle, just have a look on your parameters. They should be all normal. Everything else is taken care by the auto start system. Okay, if the auto start system is not working, it's going to revert back to the standard 737 procedures, where you're going to start your engines, and then your fuel control switches, instead of starting the auto sequence, they are going to release the fuel, just like it is for the engine start levers on the 737. Okay, so basic, the engine start levers, they are called fuel control on the 777. Okay, as we are talking about engines, let's talk about fuel. So for the fuel system, you have the same pumps as the 7.3, 2 pumps on the left main tank, 2 pumps on the right main tank, 2 pumps on the center tank. The only difference here is that you have not only one crossfeed, but you have 2 crossfeeds for the system. Okay, this improves ETOPS reliability, because crossfeed is one of the items for an ETOPS flight, and in this case you have 2, and basically that's it. You just need to use one. Okay, so especially when you are doing the fuel balance, you just run the checklist, and you are going to notice that you just need to open one crossfeed, either of them. It can be the forward, can be the aft is up to you. You do not need to turn both on, okay? Also, I do not recommend to turn both on because the system works with only one, and in case you have problem with one, you have the second one to try, okay? Maybe if you try both and then you have a problem straight away with both because something happened there on the fuel system, you do not have this second option, okay? So just follow the checklist, is going to be easy. Another thing on the 777, on top of the fuel system on the overhead panel, we have the fuel jettison system, which basically allows you to take the fuel out of this airplane through your wings, through this fuel nozzle that is right here, okay? I think that the system does not arm on the ground. If we go to the fuel system, yeah, it does. It does now. It is armed. So here you can see not only the fuel system, but the jettison system also armed. Okay. Couple of things about this jettison system. The pumps that are going to take fuel out of the center tank are the same as the standard or the normal fuel pumps, okay? So are the same pumps, they just go to a different pipe, okay? On the main tanks, you have an extra valve, you have an extra pump for that one, okay? Basically, it's a valve that is going to open and allow the fuel to go through the ducts and out of the airplane, okay? So the thing is, you have a dedicated pump for the main, and on the center you do not have the standard one. So the problem is if you have an MEL related to one of these pumps, then most probably you're going to face problems as well with the fuel jettison if you have to jettison fuel, okay? I'm not going to talk to you guys about the fuel jettison system itself, when you jettison, when you do not jettison. This is something for the non-normal maneuvers, but yeah, you do have the option to reduce your landing weight by jettisoning fuel on the 777, okay? Another thing I was going to say is the APU fuel pump. Okay, let me show you something. If you go here, basically when the APU is on, this forward pump here on the left main tank, it runs automatically, okay? You do not have to turn it on like on the 7.3. We used to keep one pump on for the APU. Here the system does it automatically, and you do not have, but the standard is to keep the pump switch off, okay? You are going to see that even with the pump switch off, if the APU is running, you are going to see that the pressure light it goes off and the system is working, okay? So let me take this pump off. So basically when you do not have fuel pressure anymore, you are going to see the pressure indication. But let's see you start the APU. Just because we just try to start the APU and we are starting the APU, you can see that the pressure light already goes off, indicating that even though this pump is off, the switch is off, the switch is off, the pump is on. Okay, so I'm going to turn off the APU, and basically when the APU sequence is completely off, you're going to see now that the pressure indication is illuminated, showing that you do not have pressure on this system. Okay, so we turn it on. This is the normal one. Like the 737, if you do not have any AC alternate current power, if you do not have AC power on your airplane, then these pumps cannot operate, and there is a DC pump for the APU. You are going to see the DC pump here on the top right side of the left main tank. So you will have a dedicated DC pump to start your APU, just like on the 737, and it even shows here on the Synoptic page if that's the case. I'm not going to de-energize the entire airplane to show you this, but that's the way it is, okay? So the fuel pump for the APU, you do not have to think about. Air conditioning, let's go to the air conditioning here on the right side. It is very similar to the 737, couple of differences. The APU switch is not on and off, it's auto and off, so basically you do not have to think about the APU switch as well. And because you do not have to think about the APU switch, because the system is going to do it automatically, there is no dual bleed light. Okay, so that light, dual bleed, that prevents you from adding thrust on your engine, on the left engine, if the isolation valve is open, or sorry, if the left engine, if the isolation valve is closed, or any engine, if the isolation valve is open on the 737, it does not exist on the 777, because the APU bleed will be off when you have bleed on that side of the system from the engine, automatically controlled by the airplane. Okay, to control this, you have not only one but three isolation valves. Okay, the center works just like the 737, is going to basically isolate the left and the right as it is on the 737, but you have two extra because this is going to help during bleed overheats. Okay, so the system will be able to isolate only the part that is not working, and you are going to keep bleed working on the rest of the airplane, and also to help you with the hydraulic pumps. Okay, let me see here if I can use this system. Which one is the best system to show? This one, the air system. This one is the best one to show. As you can see now, the center isolation is closed, just like the 737, where during takeoff you keep it in the auto position and it is closed. Okay, and then basically what we have here is left engine with left engine bleed supplying the left side, and right engine with the right engine bleed supplying the right side. Note that this valve is open to allow the bleed system from your engine to perform this way and go to your air C1 hydraulic pump. Okay, we talk about the center hydraulic systems, or the center hydraulic system itself, and the pumps. You have two electric pumps and two air pumps. Okay, to have these pumps working, you need bleed, and then the bleed comes from the engine through the left isolation valve for the C1, and through the right engine through the right isolation valve to the C2. Okay, so this allows the system to separate not only both sides, but also to control if the bleed air is going towards the air C1 hydraulic pump and the air C2 hydraulic pump. Note that the APU also can supply power straight to the C1 hydraulic pump, or through the center isolation valve to the air C2 hydraulic pump. Okay, that's why you have three isolation valves here, basically to control all this integration with the air with the pneumatic hydraulic pumps. Okay, that's why here you have three isolation. On the 7.3 for the isolation you have the open, auto and off position. On the 777 you have only auto and off. Okay, so basically you cannot force it to on, you can only close it if needed. Okay, so this is the main difference on the air conditioning system. Okay, pressurization system. Okay, pressurization system on the 777 is just like below the bleed air on the overhead panel, like on the 737. The difference here is that on the 777 you have two outflow valves. According to Boeing documents, only one outflow valve can take care of the entire airplane. So if one is not working, it doesn't matter full open, full close, the other one should be able to maintain the airplane pressurization. Okay, of course if you have bleed air. So basically you have two outflows. Of course you can take them from the auto position to the manual position, and then you have these switches. This is for the forward one, this switch is for the aft one, to control the valves opening and closing. You do not have the indication for the valves here. You will find this indication here on the main, on the ACAS indication. Okay, anytime you have any issue related to the pressurization system, this page is going to show. And then on this case you can see that your forward outflow valve is fully open. Okay, so the indication here is fully open and the valve is under manual control. The aft is fully open and it's in the automatic control, as you do not have the M. If we go up here and take the second one to the manual, you are going to see now that both are in manual, both they are fully open, and then you are going to use the system here. Let's close a little bit the forward, okay, and then we move here and you are going to see that I close the forward a little bit. Okay, then you are going to see here your rate of climb or descent for the cabin itself, okay, and your differential pressure just below. On the other side you have your current cabin altitude, and below your landing altitude, which is right now in the auto because this is fed by the FMC. So as I selected here destination Guarulhos, the airplane knows that Guarulhos is at 2,400 feet, so it's already set at 2,400 feet. Once you change your destination, the landing altitude changes automatically, so you will not have any problem in case you are diverting. You do not need to change your landing altitude. Another thing that on the 777 is automatic is the flight altitude for the pressurization. You do not have a field here to set your flight altitude. Also, your flight altitude will come from the FMC. When the flight altitude is not coming from the FMC, then the airplane considers that you are going to climb to flight level 380 and that's it. If you do not reach 380 and start your descent, the airplane is going to maintain the maximum differential pressure and eventually will reduce the cabin altitude for you to land. And vice versa. Even if you go above 380, maximum for this airplane is 43,100 feet. The airplane is going to maintain the maximum differential pressure allowed for this airplane, and you are going to stay within the pressurization limits even without your FMC. Okay, so there is no need for a field for you to select your cruise altitude related to your pressurization. Okay, so the problems of off-schedule descent you do not have anymore, and the problem of a supplementary procedure for the pressurization change when you are diverting is also not there because everything is automatic. And by the way, if you lose your FMC and you do not have your cruise altitude, and then you are not going to have also your landing altitude, then you have this button here. Okay, so this button you need to pull it to turn it on, and then one more time you are going to change and you are going to see here, in this case landing altitude is at 2,500 feet manual. Okay, so basically you come here, you take it one down, you're going to see that it changed by 100 feet, and that's it. So let's say you are going to land at 0 feet, you need to come here and take this down. Let's see how much it is now. Is at 2,200 only. Oh, and so on. Now we are already at 1,800. It's not moving really fast, but you got the point. In the real airplane is much easier, as you will be dealing with this switch while you are looking to your system here. Okay, so basically when you do not have the air synoptic and everything is under control, this goes away and you know that your pressurization is fine. Okay, so you do not have to deal with any problem with your pressurization if the system is not there. Another thing is the system synoptics. Okay, so here on this one you can select what you want to see, which system you want to see, and where you want to see. Okay, you can see it on the left side, maybe the electrical system. Okay, you can see on the lower side maybe the door. You can see on the right side maybe the air conditioning. Okay, every time you open the air conditioning, it also opens the bottom part of your ACAS display, ICAS display, and you're going to see this for the pressurization control. Okay, so this is here once you have any problem related to pressurization, or the air synoptic is open in any of these three screens. Okay, so you choose whatever you want. You can even use for your navigation display if you want. Okay, so you have the option here. The options are I will get closer. The options are, I will put here on the right side so you will see all the options. Okay, so engine, secondary engine display, status display, where you see your hydraulic, APU, and oxygen pressure always, and then the status message, and also your clock. As this one we do not have the clock, the analog clock. You have the digital one here with your UTC time, date, and elapsed time. Elapsed time will also show here on the PFD. Then you can see electric, you can see hydraulic, fuel, air conditioning, door, gear, flight control, camera system, which doesn't work on the 777 by PMDG, checklist. In this case, it's already on the after takeoff checklist. If we call the normal menu and we just take the before takeoff checklist, you are going to see that for the before takeoff checklist, you do not have to do anything. It recognizes that the flap is at 5 position and already tells you checklist is complete. Okay, it's going to be the same thing after takeoff. Okay, right now the after takeoff is incomplete, but you cannot click on the systems. Okay, you cannot say yes or no to them. You're going to see that once we take off, we take the landing gear up and the flaps up, the system recognizes that all of this is up, is going to turn green, and you have the message checklist complete at the bottom. Another thing, the communication page is this one. On the 7.3, the communication is dealt through the FMC. On the 777, you are going to have a dedicated communication page. You are still going to use your FMC to write whatever you need and to input into your communication page. Okay, for example, if you are going to request departure from Guarulhos, you have to take Sierra Bravo Golf Romeo. Okay, then you take the 80s that you have. In this case, let's presume you have hotel and we are at gate 511. You come here, you write on your FMC, and you input this into your communication page, and then you can send and so on. Okay, you can also in this case reset all of these and exit this page. Basically here I'm controlling everything with my mouse, but on the airplane your mouse is here. Okay, so you have like a screen. Screen is like a mouse. You take left or right as you need, and you have this button as your mouse click button. Okay, so you press this button and it's going to take whatever you want. So you're going to use this pad here to move, for example, to departure clearance. Okay, and then once you are in the departure clearance, you just press this button and you are going to get your departure clearance just like where you touching here. Okay, that's it. Okay, also apart from the COM, you have the navigation page if you want. Okay, as I change the navigation page to the bottom, I'm going to take it out. Okay, any page that you use, let's say gear, and you want to take out to blank the display, you just click on it again and it blanks the display. Okay, so these are the synoptic displays for the 777. And the landing gear, you have 8 auto brake position instead of 6. On the 73 you have only 6. On the 777 you have 2 extra. The first extra is the disarm, and the second extra is the auto brake force. So basically you have auto brake RTO. On the 777, once you take off, the RTO goes automatically to the off position. On the 73 it doesn't do it, so you have to take from RTO to off in flight. Okay, it does it automatically on the 777. And in flight, once you select auto brake 1, 2, 3, 4 or maximum manual, and you take your auto brake off, the same as the 737, using your brake pedals, retracting your speed brake, increasing thrust. What else you can do? I think that those are the things. Yeah, or you come here manually and turn off your auto brake. Okay, basically if you are doing automatically, it goes to the disarm position. Okay, it does not stay there. Okay, so anytime that the auto brake for landing disarm, it goes from the position you select, maximum auto 4, 3, 2 and 1, to the disarm position, and then after landing you take it to off. Okay, on takeoff, from RTO to off it goes automatically. On landing it goes automatically to disarm, and then you take it to off. Okay, so this is basically the auto brake settings. And the landing gear, you do not have the off position, just like the 737 MAX. Okay, so you have down, and once you put it up, the hydraulic system is going to retract the landing gear, and after a time delay, after a few seconds, the hydraulic pressure will be removed from the system automatically. You do not have to take it off as on the 737 NG, but I think my friend and most of the pilots that are using or flying the MAX already know how it works. It's the same as the 737 MAX. Okay, no need, and there is no off position. What else? Oh, this is a nice one. Navigation radius. Okay, navigation radius, we have it through the FMC. So there is a page here called navigation radius, and here you can select the VOR by frequency or by identification, the course that you want. It will always show the radio that you are right now, and you also can select ADF here, left and right. Also you have the ILS frequency. You only need to select one. Okay, in normal condition, if you select ILS here on the left, it doesn't matter if it's on the left, on the right. Once you change one, it's going to change the other one. Okay, and basically for the ILS you have 3 ILSs, as you can see here. If you want to identify the approaches and the markers, you have for the left ILS, the right the center ILS, and the right ILS, and the markers. Okay, so here you choose which one you want to identify, and basically you do it through here. One important thing is that this can be done automatically by the system. Right now we have automatically selected 11.7095 because we have our approach here to Guarulhos, and we are close to Guarulhos. Okay, in flight, if we change the procedure, as we change the procedure here for arrival, okay, it's going to change also automatically the ILS indication. Okay, it changes automatically if this is in auto and you didn't pre-select something, because you can always pre-select like 110.9 and course 169 like Congonhas, and now you select Congonhas. It is telling me that the runway ILS frequency is error because it does not correspond with the one I selected on approach. Note that this changed to M, which is manual indication. Okay, so I can clear, and I'm supposed to delete this indication. It goes back to automatic 110.70095 for my approach. Okay, for the VORs, you have also auto, manual. So let's say I want to select, I think San Jose is 12.8. Yeah, so, or something else, okay, it doesn't matter. Now is Golf Romeo Delta 12.8, and there is an M for manual. Okay, if I delete this, it's going to, it was supposed to go back to automatic. It's not automatic one because right now there is a P because of procedure. So when I selected my departure here, AMVU for Alpha, the system has the VORs that it needs to be selected for this departure. Okay, so in this case, because of the departure procedure, you have 116.9. Also, if it's not part of a procedure itself, but it is along your route, you are going to see a Romeo here, which means is a VOR set along your route. Okay, so if you do not have one for the procedure, if you do not have one along your route, then the next step is automatic tune by the system. It's going to show an A, and the fourth step is manual. So in this sequence, okay, procedure, route, automatic, and manual. And anytime you select a manual, the system cannot auto-tune for the automatic, for the route, or for the procedure in that order in reverse. Okay, so this is the navigation radio, and as I showed you, you select the frequency and the course, and for the VOR you select the VOR and the course on the line below, on the second line. Okay, you can always pre-select. Let's say that our here in Guarulhos, let me show you here. Let's go to the electronic flight bag and let's search for Guarulhos approach. 10 left is 110.7095. Okay, so you can come here and put 110.7/095, and you can keep here on the pre-select. Okay, the right side is 111.7 and also 095. You can keep here on the right side, for example. So then I know that my ILS on the left is 110.7/095, on the right is 111.7/095. So if I'm flying and I have no time to change the procedure, but I'm going now to land on the runway 10 left, I just take this and put on the ILS, and it's working already, the ILS manually. Okay, oh no, that's not the one that I want. I can pre-select this one and just take it to the ILS. Okay, now it's manually selected and there is no error message because I have the correct one. Anyway, I can delete and leave it in automatic, which is the normal mode. Okay, the pre-select you can do for the ILS and for VORs, and or even for course. Sometimes we even put the gate that we are going to land. So let's say that we go today for 511, we just put here 511 and it accepts because it's not taking anywhere. It's just a pre-select that once you have 511, for example, you can take on the ADF. That's why it allows. You can even take, for example, let's say that you are landing in Frankfurt and you go to position Delta 1, you can take Delta 1 and pre-select here. Let's say that you have 300 passengers, you are not using the pre-select and you want to put here 300 as a reminder, is up to you. Let's say your flight number is 1986, you can take 1986. Actually 4 numbers you cannot. Okay, I'm sorry, 4 numbers you cannot. But you got the point. Okay, for gates usually it works, and for a number of people on board also works, and if you want to pre-select any radio you can do it as well. Okay, so that remind me that you do not have the course here on your autopilot, okay? The windows here are only for speed, heading, vertical speed and altitude. You do not have the courses here, and also you do not have the for lock button. You have only lock, okay? If you want to fly VOR, you need to fly through your FMC, or you need to take it to the VOR and use heading cell or tracking cell, and then you fly with your needles, okay? If you want to fly it automatically like we do, let's say that you want to go on CGO Congonhas radial 095 out, you take CGO. It did not accept because CGO is not here. Let me think about something. CGO, this is the VOR. Oh, it didn't allow me because of the procedure itself. Okay, let's assume that I want to go Congonhas after VMAP, okay? Then it's 69, it allows me, okay? So I want to go on Congonhas, in this case 030 after 218. It was supposed to allow me, so CGO 030. I don't know why it's not allowing me. Yeah, you just take the radio that you need. In flight we can do it. I'm going to show you in flight. It's not accepting because we are still on the ground and the flight plan sequence does not make sense, but yes, you can do it. You can select the radios. On the 7.3 you can do something similar, but on the 7.3 you need to specify a distance. On the 777 you can do an inbound intercept just like on the 7.3, but you can take a radio outbound without distance, okay? It's going to create a line without distance, and that's it. You can fly with LNAV. I'm going to show you in flight, okay? What else? There is a really nice light control system which I'm going to show you like this because I want to get really close to this button. Okay, so the master bright is on. If I click, you just notice that this went out a little bit, so it's not working anymore. So to be on, it needs to be in, and then you can control all your lights through this button here. Okay, you're going to see that all, for example, in this case, all my displays, they are going to a low bright because I'm setting all of them, or I can take it full bright if that's the case. Okay, so you can use only the master bright to work all the buttons that you have the small dot. Okay, all the buttons, the small dot, if you keep the switch itself on the small dot and the master bright on, everything that you are doing on the master bright is like you were doing on these switches. In this case, the overhead, the glare shield, and also here about, oops, why the camera is not working properly, and also here on the outboard display, inbound, this inboard display, and the panel. Okay, also here on the IO stand panel, and that's it. Okay, these are the switches that are automatically changed if you keep them on the dot and you use the master bright switch. Another thing that we have is the evacuation signal. Here there is an evacuation command. So usually it depends on the company that I fly for. When we have to evacuate, the captain will come to the passenger address and say evacuate, evacuate, evacuate. Okay, so basically evacuate 3 times, and then you come here to this system and you activate. Okay, I'm going to give you the sound. This is the sound. Beep, 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 beep. Okay, I will give you one more time. Okay, once you command, you do not want to turn it off, you just want to shut off the beep 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 on your head, you use the horn shut off button, okay? And the evacuation signal is still on top of each emergency door, and you are going to see you are going to hear on top of each emergency door this same sound, okay? Basically telling you, the passengers, okay, there is an exit this way. Beep 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 is like, come this way. If the door is not being used for evacuation, then the cabin crew, they have to go there and deactivate this alarm, and that's it. The alarm goes off, just like it goes off here when you press the horn shut off to pull, okay? And also here you can test itself, even if it's off, you can press to test. Okay, so that's it. Let me take the audio off again so we can keep talking. And well, the taxi camera I cannot show, but basically you have on the upper part camera showing your nose gear, and on the lower part your left side and your right side, okay? If you go outside, you are going to see that on top of the wings on the 777-300, you are going to see this red, I'm getting crazy, these black markings here. Okay, these black markings represent the edge of the wheels. Okay, so on the camera itself, it's really hard to notice where are the wheels, but you use the black strip here as a reference for your wheels. Okay, especially at night, it's really difficult to see, and you can use this stripe here. This stripe is only here because of the taxi camera. As you can notice, many 777-200s or all 777-200s, you are not going to have the taxi camera, so you are not going to have this strip here. Okay, so basically it shows you where the gears are. Okay, nice and easy. Another thing that I want to show and I'm going to discuss during the flight is the autopilot altitude capture mode. On the 737, you have two modes. Let's say you are climbing in level change and you are reaching the altitude on the autopilot programmed on the MCP. So you will be climbing, and close to that altitude, the airplane will capture this altitude, and the FMA changes to altitude acquiring, and then it changes to altitude hold. On the 777, it's only one mode, and this mode is out, which means altitude. Okay, so the thing is, once you enter in the out mode, it means the altitude is being captured and is going to be maintained. The big difference is on the 73, if you are climbing or descending, the airplane enters in altitude acquiring mode and you change your altitude window, the airplane reverts to vertical speed with your current vertical speed. On the 777, it doesn't work. Once you have out, the airplane is going to level off at the altitude that was selected. You can take altitude selector up and down, the airplane will level at the previous altitude selected. Okay, so one thing to remember is this. Let's say that you are climbing to 5,000 feet and then ATC tells you to climb to 6,000 feet. On the 737, if you are in altitude acquiring and then you change to 6,000, the airplane is going to engage in the vertical speed with that current vertical speed, and maybe it's around 700, 500 feet per minute is good enough for you to climb another 1,000 feet and you don't have to do anything else. And then the airplane is going to enter altitude acquiring later on when you're reaching 6,000 feet. On the 777, it doesn't work like this. On the 777, the airplane is going to level off at 5,000 initially. Even though you change to 6,000, you need to give another command for the airplane to continue climbing to 6,000 feet. Another thing, and that's I'm going to show you and explain during the flight, is that when you have VNAV and you are extending your flaps, the airplane follows the speed on the FMC and disregard the flap position. Okay, even if you do not extend flaps and you have a speed lower than the flap up speed, the airplane is going to reduce to that lower speed. Okay, so on the 777, basically you do not have automatic speed selection based on your flaps. So every time you are on approach on the 777 with the flaps extended, you have to open the speed window in VNAV path and control the speed manually. Okay, so the speed will be always controlled for approach with the MCP. It doesn't matter if you are on a ILS or in VNAV approach. Okay, on the 73, you also have to select the speeds for the ILS once you have glide slope capture, at least, but on the 777 you have to do always, okay, for the ILS and also for the RNAV. We are going to shoot an RNAV approach, and I'm going to show you that. Okay, so I talked a lot about the 777, the difference between the 777 and the 737. Let's try to make a flight. A couple of differences also on the takeoff. Here you are going to see that once I press toggle, I will have thrust reference. Thrust reference is the same as N1 on the 737, and thrust is basically reduced thrust. Okay, so if you have thrust, it means that maybe you do not have full thrust, and if you have full thrust like N1, you will have thrust ref annunciated. Okay. Throttle hold is only hold, and the auto throttle arm is hold as well. Okay, so every time you have, for example, level change descent in idle, the airplane is going to bring the thrust lever to idle, and once it's in idle on the 737 it changes to arm, on the 777 it changes to hold, but the design is very similar. The only difference is that on the 777, if you use the flight level change for your climb or descent, the airplane is not going to reduce to idle thrust immediately during a descent or increase to full thrust during climb. Is going to reduce and increase the thrust slowly, and if the airplane calculates that it can reach the new altitude within 2.5 minutes, the airplane is going to keep that thrust. Okay, so maybe you are going to have a climb with less than full thrust and a descent with less than idle thrust. Of course, once it reaches the thrust that is planned, this can change to hold on the 777, and then you can move your levers freely. Okay, so if you are descending, the airplane is not in idle and the thrust and the auto throttle is in hold, you can always override, bring it to idle, and the airplane is going to be doing a level change descent just like the 777. So sorry, just like the 737 on the 777. Okay, so it's a soft mode for the level change to improve passenger comfort. Okay, that's it. So I'm going to take my camera off, and here we go. Another difference on the 777, we do select toga at 55% N1. Okay, so instead of 40% N1, let's take the brakes out. I don't think that yeah, parking brake is out. So you take your thrust to 55%, and then you press toga, and not 40% like on the 7.3. Everything else is the same, a little bit of forward pressure until 80 knots. 80 knots it enters in hold instead of 86. Also above 85 you have auto brake, Oh, I do not have the sim audio. I'm going to give you the sim audio as soon as I take off. Positive rate, gear up. LNAV, 200 feet, we can engage autopilot. Here we go, and let me give you the audio. Yeah, now you can hear the audio as well. So the airplane is in thrust rev, which means full thrust, LNAV and VNAV speed for now. 1000, climb thrust, and speed to 240, which is current flap -5. Remember, this is flaps 5, the current one that we have. We have to retract flaps to 1. And now, once we have flaps 1 and we are above 1, it tells me that I have to retract flaps to up. And that's it. Now the auto brake switched automatically to off. So now that everything is in place, flap is up, landing gear is up, you can do after takeoff. To do after takeoff, you just press the checklist. It says after takeoff checklist is complete, you close, you are done. Okay? So let's say that we wanted to climb to... this switch is not helping me. To 7,000 feet. Okay? I'm going to show you once we have altitude acquiring. I can change speed VNAV out. Now I change to 10,000 again. The airplane does not climb to the 10,000 feet, okay? Because the out was captured to 10,000 feet. You are going to see that the airplane levels off at 7,000 feet. It will be the same with level change. So level change, thrust, flight level change speed. The airplane is not going to add full thrust, is going to add thrust just enough to climb to 8,000 in up to 2.5 minutes. And of course you can always override this thrust if needed. If you want, okay? It also works on vertical speed. Let's say I'm climbing with 2,000 feet per minute. And now you're going to see that I'm going to have speed and out. And I change during out to 20,000 feet or whatever. 10,000 feet we're going to set initially. So out, I change to 10,000. The airplane does not re-engage in VS like on the 7.3. It captures the previous selected altitude. Okay? So here we go. Our cruise level today is 200 and we can take VNAV. Thrust rev, VNAV speed, 8,000 is transition level. We can set altimeters to standard. Always keep your heading bug ahead. So this is our short flight today. Climbing to 20,000 feet. Another thing on the 737, if you have takeoff reference page, once you are airborne, it changes automatically to climb page. That's not the case on the 777. You have to do it manually. Another thing, on the 777, you do not have climb, cruise, and descent. You have a VNAV page, okay? And instead of the other two pages, you will have one page for the alternate, okay? And one for the FMC com, okay? So FMC com and alternate, they replace basically cruise and descent, and the VNAV replaces the climb, and you have the VNAV as page 1, 2, and 3. First one is climb, second is cruise, third is descent, okay? Also, you do not have N1 limit page because you have nav radius page. So if you want to go to N1 limit page, you have to go initial reference and then in flight you are going to see thrust limit if you are in climb. Once you are in cruise and you press initial reference, it goes to the approach page automatically. But even if you are on the approach page, it doesn't matter, you can go to thrust limit anytime, or even on the index you will find your thrust limit as well. Okay, so that's it. The good thing about the VNAV page is that every time you press VNAV, it's going to open automatically at the current phase of flight. So basically, if you think the airplane is on descent, but then you press VNAV and it's still on cruise page because you didn't select, for example, the descent now that is going to show during cruise, it means that the airplane never reached the top of descent or never enter in the descent mode. Let's say that I'm not sure, I'm not even looking to my screens and I press VNAV, I can tell you that the airplane is on the climb phase, because every time I press VNAV, it opens on the correct phase of flight. Okay, climb for now, and I'm going to keep on legs. We are going to see the airplane reaching flight level 200 soon, and I'm going to show you that. By the way, I'm going to prepare my descent with auto brake 3. Recall is here. There is a button for the cancel and recall. And the checklist, there is no notes for this checklist. My landing is going to be with flaps 30, 142, and that's it. Minimas. What are my minimas for this approach? 2651. So all set. I can do my descent checklist, which states for recall checked, notes checked, auto brake is 3, landing data VRF 3142, minimums 2651, approach briefing completed, descent checklist is complete. Let me go here to the N1 limit page and select maximum climb thrust. So the climb goes to maximum thrust. So we can reach 20,000 faster. One thing that I usually fly with is the airport. Let's take the airport one more time. So this is 1,000 to go. Speed VNAV path, the airplane reaches 20,000. I'm going to change my approach. I'm going to change to RNAV X-ray 10 right through Lomen, and everything is set. So it says now that I'm in cruise, if I press VNAV, it goes automatically to the cruise page. Look, already in the page 2 of 3. Not in the page 1 of 3 anymore. Okay, as we are getting close to top of descent, my next restriction is flight level 80, so I can come here and change to flight level 80. The airplane is going to start the descent automatically. Another thing, the 737 have different VNAV modes for descent. If you open the speed window, some airplanes they keep on profile, some airplanes they revert to VNAV speed, some airplanes you can have a VNAV speed, and once you reach the profile it's going to add thrust to maintain the path and so on. On the 777 this is not the case, okay? So basically, anytime you are in VNAV, you can have VNAV path or VNAV speed. However, anytime you open the speed window, it reverts automatically to VNAV speed, and it never goes back to path unless you reach an altitude restriction. Okay? So, speed window open, you have VNAV speed on your descent. On approach is the opposite. It doesn't matter if the speed window is opened or closed, and you are on approach logic, the airplane will remain in VNAV path. Okay, so I'm going to close, it goes to VNAV path, idle, and is going to catch the path again. So that's it. 8,000 is below transition altitude. I can set my altimeters to 1026. Transition level is 085 here in São Paulo. Okay, so I can do my approach checklist, which states for altimeters 1026. Approach checklist is complete. Note that now that I have an RNAV approach selected here, RNAV 10 right, I go to the nav radius page and there is no indication for my ILS, okay? So no indication for the ILS. Note, as I told you, if you have the speed window closed, the VNAV can go into VNAV speed or VNAV path, okay? It goes into VNAV speed if you are away from the path, okay? It's coming back slowly, and we are going to leave like this, and you are going to notice that once the airplane reaches 150 feet to the path, this changes to VNAV path, and the airplane is going to start maintaining the path from this point. What happened is, because I changed the altimeter to 1026, we were high on profile, and then the airplane is having the difficulty to maintain the path. That's why it reverted to VNAV speed. Also note that on the descent forecast page, there is no space for you to enter your QNH and your ISA deviation, okay? So the VNAV path cannot compensate for the ISA deviation and the QNH. Basically, for the ISA deviation, you can, if you come here on the route data, and for the wind, and you change, and you tell them that at 2,500 feet, you are going to have there on runway 10, you are going to have temperature of, what is the actual temperature now there? Let's go here and select 21 degrees. So you can go all the way there and select 21. Okay, so it kind of compensate on the real airplane. On this one, on PMDG, is not going to change. Note 150 feet, speed, and VNAV path. Okay, on the descent forecast, you only have the option for anti-ice on, thermal anti-ice on, and not on and off as well. So it calculates with anti-ice on from the altitude that you select until the ground, but you have a fourth altitude layer for your wind direction and speed. Apart, the 73 is only 3, that's why you have a couple of other options here. By the way, the transition level is in the forecast descent, but the transition altitude is on the VNAV climb page, okay? On the performance initialization, you have minimum fuel temperature here and step size for the step climbs instead of the transition altitude and top of climb wind. Okay, so these are the main differences for these pages. Note that here we have at some point 170 at observe. If I don't do anything, the airplane will reduce to 170 at observe. If I stand the flaps or not, the airplane is going to do it, okay? That's why during the approach, you want your speed window open. I will have to stop for a while. I had something I have to do. I come back in a minute. I'm sorry guys, I had to deal with house duties here. Let's go back to our flight. So we are going down, as I told you before, VNAV path. I like to keep this page descent, so I know my next constraint, if I'm going to make it or not, what is the speed that FMC is planning. And also on the right side, I really like when the pilot monitoring keeps legs page, so I can see my next restrictions related to altitude and also speeds if they were there. By the way, on the 777, you cannot enter a speed restriction if you do not have an altitude restriction, okay? So if you want to enter a speed restriction, you will always need an altitude restriction. For the altitude, it's fine to have the altitude without the speed, but for the speed you need an altitude, and also the speed, it is always considered at or below. So if I set 200 slash here, it means it's 200 slash here, it means it's 200 or below. Okay, you cannot add 200 or more above, or 200 or less below. On the 777 is always at or below speeds. That's the way FMC interprets your speed restrictions on the legs page. Okay, so we are about to reach 10,000 feet. The airplane is not reducing properly, so what the airplane is going to do is going to maintain 10,000 feet. We are going to see the speed, the FMC message drag required, just like on the 73. So the airplane is going to reduce to 240. Eventually the path is going to be low, and then the airplane reverts to VNAV speed. Okay, so now hold. You can use your thrust as you want. Okay, now we want in idle, we don't want more than this, and the airplane is going to reach 240 and then start the descent on profile. Okay, another thing, our next constraint is still 8,000 or above. The next one is 8,000 or below, and then 6,000 or above. So we can change this to 6,000. Reducing very, very slowly. We are already 800 feet high. We can use the speed brake to go down, help the airplane to go back to VNAV path. And I want to show you that once I extend the flaps and I open the speed window, the airplane is going to keep VNAV path if we are on path. So speed window open on the descent is always VNAV speed. Speed window open on the path during approach is always VNAV path. So VNAV path, I can take my speed brake out. I can take this back to auto, because the next step for us is 5,100. So 6,000 we are going to reach, and now I want to start reducing. Okay, I can open my speed window and reduce, because the airplane has sequenced the approach fix. It maintains VNAV path, and now I can start extending my flaps. Okay, so the airplane is on approach logic, so maintains VNAV path even with the speed window open. And now we can even reduce our speed to flap 1 speed as we want. Okay, and there we go. That is 1,000 to go. We are on VNAV path. We know it's going to cross at 6,000. Next altitude 5,100. We can take flaps 5 and maintain 200 knots for now. Really soon is going to be turning on heading 146, so we'll pre-select 146 here. We can reduce to something close to 180 knots. It's a good speed for these turns during the procedure. Also, you do not want to intercept final really fast. Some tailwind here for our approach. Not a big deal. 6, 7 knots only. 5,100 is going to cross. Next altitude is 4,500. So the airplane is on path, reaching the speed, adding a little bit of thrust to maintain that speed. Next altitude 4,100 for the final approach fix. We'll be turning to the final, heading 095. Rig soon. I would wait to observe to select 3,300 and then to the next constraint to select the minimas. But note, I want to show you now that the 777 you can select your minimas rounded up to 10 feet. So in this case we select 2651, so we can select 2660 here. Okay, we are approaching the final approach fix. This is approaching glide path 2 miles to go. And at 2 miles to go, that's the time that Boeing tells us to take gear down, flaps 20, and then you reduce the speed towards flaps 20 speed. At final approach fix, you're going to cross-check your altitude. It's supposed to be 4,100 or above. Basically 4,000 for this, 4,100 for this approach, and that's what we are going to see. So approach fix right now 4,100, and we can select landing flaps 30. We reduce our speed to VRF plus 5, our approach speed, and the auto throttle, sorry, 147, and the auto throttle stays on during approaches on the 777. Now that we have flaps going to 30, we can do the landing checklist. We arm the speed brake. I forgot to arm the speed brake when we set gear down flaps 20, so landing checklist is complete. We can close. The only thing that we need is to set our missed approach, which is 6,000 feet. So I'm going to select missed approach 6,000 feet. And we cross now 1,000 feet, or we are about to cross 1,000 feet stable for this approach.
1,000.
Okay, and here we have Guarulhos ahead of us. I'm going to try to fly manually. I'm using an old joystick. I do not have my full setup here, but basically here we go. I really need to get closer to this, something like this, so I can really see the speed. That's not the best camera. If you have a big monitor, take zoom out as much as you can. It's going to improve your landings.
400.
Okay, so autopilot off.
300.
I will try to maintain flight director as much as I can for this approach. This is going to take me down to the threshold at 50 feet.
Approaching minimums. 200. Minimums.
Landing.
100.
Slightly low. That's correct. Cross the threshold at 50 feet. And keep going down.
20.
And okay, speed brake up. Idle reverse in this case is good enough. We are going to have good speed for the second high-speed taxiway here in São Paulo, which is Charlie Charlie. So 60 knots, idle reverse, manual brakes, auto brake, and we are reaching now 40 knots. With this speed, we can take out of the runway this airplane to the left here. Okay, here we go. As we vacate the runway now, this is the time for you to start braking and bring, in this case I'm going to bring the airplane to a complete stop here. Okay, complete stop. I'm going to set parking brake, and here we are back in Guarulhos. Not the best landing, because you really want to see, if you do have a big screen, you want to get your view something like this. Okay, so you have a better view of all your surroundings. You can even see the runway passing by on your left window, and it's much easier for you to control your nose attitude if you have a wider view of your screen. Okay, but this way, on the notebook that I'm playing here, I can barely see my speed, I can barely see my flight director, so I was not able to do like this. Okay, so guys, I hope you enjoy this session, basically explaining you the main differences between the 737 and the 777, and then a short flight departing from Guarulhos, coming back to Guarulhos, to show you a couple of differences on the autopilot, and basically what is very important on the 777. If you are on the descent, you open the speed window, you will always get VNAV speed. If you are on approach and you open the speed window and you are on the profile, you will remain in VNAV path. So basically what you want during your RNAV approaches, you want to be on the path, and then just before starting extending your flaps when you are inbound the procedure, or once you extend your flaps 1, if you are far away, then you open your speed window, and this is the time that you are going to start controlling your speed as if you were in an ILS approach, where you need to select your flaps and select your speeds manually. Okay, on the 777 you will have to do it always. Okay, so remember, VNAV approaches, they are with the speed window open and you control the speed manually. It is a little bit different than the 737, but is more similar to an ILS approach, where you have to configure your speeds manually. So in that sense, it's a little bit easier, because you are going to do for every single approach the same way. You just have to remember to open that speed if you are on VNAV. Okay, so this is very important. I forgot to show you how to get out on a radial from a VR. This was a really short flight, I'm sorry. However, you just take the identification of the navigate that you want to fly, and you take the heading that you want to go out with 3 digits. If it's 008, you have to put 008. If it's 045, you have to put 045, and if of course it's 329, you have to put 329. So always with 3 digits, and the FMC is going to create a line out of that navigate, or any fix that you have, anything that is on your FMC database out on that radio, out on that course, and you can use your LNAV to intercept and follow that one. Okay, on the 73 you can do only intercept once, just like this. Let's say you are on the legs, you want to go direct to Izimu, you can do an intercept course from radial, let's say 095, is going to create for you the 095 radio inbound. Let's take this. It's not even showing here because we are already on the ground, but basically, you know my point. If I take here Izimo, and then you are going to see that it goes inbound 095. Okay, so this is inbound 095. So you can do outbound as well. You just take Izimo 095, and it was supposed to, oh, you see, now it accepted. I don't know why it didn't accept it before. So now you take Izimo, let's say that this was a VOR, Congonhas for example, and then you put 095, it creates 095 on the heading, and then you can use your heading or tracking cell to come to this radio here, and then you arm your LNAV when it's getting closer to the route. It's going to intercept LNAV and follow LNAV as you were going out on a specific radio, in this case radio 095 out of Izimo. Okay, so I was not able to show you in flight because I forgot, but that's the way it is. Okay, so if you like this video, if you learn anything during this short 2 hours, give me the thumbs up, share with your friends, and I see you on the next video. Bye bye.